In today's lesson, we're going to be talking about the completing the square process to solving quadratics. Here's a list of steps that we're going to be following when we do the completing the square process. The first step is we want to gather all variables on the left side and all constants on the right side. So our format of our equation, we want in the form ax squared plus bx equals c. So notice all x terms are on the left and the constants on the right. We're going to divide everything through by the lead coefficient of a. When we do this, the lead coefficient will then become 1. Step number 3, we're going to take 1/2 the coefficient of the x term, square it, and add this quantity to both sides of the equation. So the process, in other words, we're going to take b divided by 2 squared and add that to both sides. Step number 4, we're going to factor the perfect square trinomial that we've made on the left side and simplify the right side of the equation. The left side is always going to factor into the form x plus b halves squared. Now, you can also use the AC method that we've talked about in previous lessons to factor that left side if for some reason you don't remember the pattern. Step number 5, we're going to use the principle of square roots. Step number 6, we are solving the remaining equation. And 7, it's always a good idea to check your answer in the original equation. All right, let's take a look at some examples. Our first example says 2x squared minus 4x minus 30 equals 0. Our first step is to gather all x's on the left side and all constants on the right. So we see both x terms are already on the left side of the equation, but this minus 30, we want to move to the right side. So we're going to add 30 to both sides of the equation so that it moves that constant to the right. So we get 2x squared minus 4x equals 30. Our next step is we divide by the lead coefficient. So our lead coefficient is 2. So I'm going to divide everything through by 2. This makes that lead coefficient 1. 2 divided by 2 is 1. So 1x squared, or just x squared, minus 2x, if we simplify that x term, and 30 divided by 2 is 15. All right, this next step is where we take the coefficient of x, which in this case is negative 2. That's the b term. We divide it by 2 and square it. So negative 2 is our b term. We're dividing it by 2, which we get negative 1, and we're squaring it. So that gives us positive 1. We're going to add that to both sides of the equation. So we get x squared minus 2x plus 1. This is now a perfect square trinomial on the left. And in order to keep the equation balanced, we're going to add that 1 to the right side as well. This left side is now factorable. So the factored form is x minus 1 quantity squared. Now, you could do the AC method to get that factored form, or you can remember that it's whatever this b value is divided by 2 will take on this number inside the parentheses. So it'll always look like x minus plus or minus b halves squared. And if we simplify the right side, 15 plus 1 gives us 16. So now we're going to solve using square roots. So square root both sides to get rid of that power of 2. We get x minus 1 on the left, and we square rooted both sides, so we need a positive or negative, and the square root of 16 is 4. This actually makes 2 equations. We have x minus 1 could equal positive 4, or x minus 1 could equal negative 4. If we solve both of these equations for x, we get x equals 5 or x equals negative 3. Here are my two solutions. It is a good idea to check both of those solutions to make sure that they both satisfy the equation and make a true statement. So if we plug in the first one, 2 times 5 squared minus 4 times 5 minus 30, we're asking ourselves, does that equal 0? Well, 5 squared is 25, times 2 is 50. 4 times 5 is 20. So we get 50 minus 20, which is 30. 30 minus 30 does equal 0. So that first solution checked. Second solution, x equals negative 3. If we plug that in, 2 times negative 3, quantity squared, minus 4 times negative 3 minus 30. Does that equal 0? Well, negative 3 squared is positive 9 times 2 is 18. Negative 4 times negative 3 is positive 12. 18 plus 12 is 30. Minus 30 does equal 0. So the second solution did check as well. So we do have two answers, x equals 5 or x equals negative 3. Our next example says x squared plus 14x minus 51 equals 0. My x's are already gathered on the left side, but I do want to move this constant to the right. So we're going to add 51 to both sides of the equation. We get x squared plus 14x equals 51. Our next step is we divide by the lead coefficient. Our lead coefficient is 1. So if we were to divide everything through by 1, it's not actually going to change this equation at all. So we don't need to do that step. However, the next step, b divided by 2, quantity squared. We're going to take 14 divided by 2, which is 7, and square it, we get 49. We're going to add 49 to both sides of the equation. So we get x squared plus 14x plus 49 is equal to 51 plus 49 to keep that equation balanced. Okay, our left side is a perfect square trinomial. Again, we could use AC method to find the factored form, but using the pattern, it is going to be x plus b halves, which in our case was 7, quantity squared. And if I simplify the right side, I get 100. Using square roots to solve, we take the square root of both sides. We get x plus 7 is equal to positive or negative 10. If we split this equation up, we have x plus 7 could equal positive 10, or x plus 7 could equal negative 10. Solving both of these for x, we get x equals 3 or x equals negative 17. Again, we should plug these back into the original equation to see if they check. Here's our next example. 3x squared minus 36x equals negative 33. We have our x's on the left side, and our constant is already on the right. So we don't have to rearrange the equation at all. But our lead coefficient is 3, so we do need to divide everything through by 3. If we do that, we get x squared minus 12x equals negative 11. Next step, we're going to take our b divided by 2 and square it. We have negative 12 is our b value. If we divide it by 2, we get 6, negative 6. And if we square it, we get positive 36. So we're adding 36 to both sides of the equation. Our left side is now factorable using the pattern x plus b over 2, which in this case, b over 2 actually gave us negative 6. So I'm going to write that as x minus 6 quantity squared. Again, you could use a C method to get that if you don't feel comfortable with the pattern. And if we simplify this right side, we get 25. All right, if we use square roots to solve, we get x minus 6 equals positive or negative 5. Splitting that up into the two equations, x minus 6 could equal positive 5, or x minus 6 could equal negative 5. And solving this equation by adding 6 to both sides, we get 11 or 1. Again, we should check those by plugging those back into the original equation to see if, in fact, it makes a true sentence. All right, our next example says x squared minus 7x equals 18. Our variables are already gathered on the left, and our constant is already on the right. Our lead coefficient is 1, so we don't need to divide everything through by 1. So we're going to jump right into the step where we take b divided by 2 and square it. Our b value is negative 7. So negative 7 halves squared. So negative 7 times negative 7 is 49, and 2 times 2 is 4. So we get 49 fourths. That is what we're adding to both sides. The left side of the equation is now factorable. It is a perfect square trinomial, and it is much easier to use the pattern since we have fractions with this one. So if I use the pattern x plus b over 2, the b over 2 value was negative 7 halves. So minus 7 halves quantity squared. And to simplify this right side, I would need a common denominator of 4. So if I rewrite 18 over 1 as a common denominator of 4, I'd multiply both the top and the bottom by 4. 18 times 4 gives me 72. So 72 fourths plus 49 fourths. That gives us 121 fourths. Okay, let's use square roots to solve. So if we square root both sides, we get x minus 7 halves equals positive or negative. The square root of 121 is 11, and the square root of 4 is 2, so 11 halves. We're going to split that up into the two equations. So x minus 7/2 could equal positive 11/2, or x minus 7/2 could equal negative 11/2. Solving this, we would add 7/2 to both sides. So over here, we would get 18/2, which simplifies to just 9. And on this one, if we add 7/2 to both sides, we would get negative 3/2. So our two answers, x equals negative 3/2 or x equals 9. Our next example says 6x equals 4x squared minus 1. We need to gather all of our x's on the left and our constants on the right. So we need to move this 4x squared. So I'm going to subtract 4x squared from both sides of the equation. We would get negative 4x squared plus 6x equals negative 1. Let's divide everything through by our lead coefficient of negative 4. We get x squared minus 6 divided by 4 does reduce to 3/2. And negative divided by negative does make a positive, so positive 1/4. Okay, we have b divided by 2 quantities squared. This time b is a fraction. So I'm going to think of that as 1/2 times b quantities squared. And my b value is negative 3/2. So if I multiply 1/2 times negative 3/2, we would get negative 3/4. And then squaring that value, we get 9/16. So we're adding 9/16 to both sides of the equation. Okay, that left side is factorable. Again, it's going to be so much easier using the pattern. So the pattern, we have x plus b halves. For b halves, we got negative 3/4. So minus 3/4 quantity squared. And on the right side, we do need to find a common denominator again. Hopefully we're okay with that's 4/16. So if I add that to 9/16, we do get 13/16. Square rooting both sides, we get x minus 3/4 is equal to positive or negative root 13 over 16. Splitting that up into two equations, x minus 3/4 could equal positive root 13 over 4, because the square root of 13 is not perfect. And x minus 3/4 could equal negative root 13 over 4. All right, we would add 3/4 to both sides. On this left side, we get x equals 3/4 plus root 13 over 4. And again, we would add 3/4 on the right of side equation as well. And we get x equals 3/4 minus root 13 over 4. Notice the only difference between these two answers is the sign in between the two fractions. So you may see the answer written like this: x equals 3/4 plus or minus root 13 over 4. That means the same. So if you want to use that shorthand, you can. Okay, the last example that we're going to walk through together says 9x squared plus 79 equals negative 18x. We need to gather all of the x's on the left side and all the constants on the right. So I'm going to add 18x to both sides. And I'm going to subtract 79 from both sides. So we get 9x squared plus 18x is equal to negative 79. Next step, we're going to divide that lead coefficient. And we get x squared plus 2x equals negative 79 ninths. Okay, b divided by 2, quantity squared, is our next step. So we have 2 divided by 2, quantity squared, we get 1, and square it, we still have 1. So we're adding 1 to both sides. That makes this left side a perfect square trinomial. Factored form of that would be x plus b over 2, which b over 2 was 1, quantity squared. And here again, we need a common denominator. That's 9 ninths. So we would get negative 70 over 9. Okay, using square roots, we get, I'm going to pull that up here, x plus 1 is equal to positive or negative root negative 70 over 9. Again, we're going to make that into our two equations. So x plus 1 could equal positive root negative 70 over 9. Or x plus 1 could equal negative root negative 70 over 9. Sorry, that's a little scrunchy on the edge there. If we solve both of those equations by subtracting 1 from both sides, we get x equals negative 1 plus root negative 70 over 9. Or we get x equals negative 1 minus square root of negative 70 over 9. We need to clean that up a little bit. So first of all, we see a negative underneath the square root. So we're going to have an imaginary solution. So I'm going to pull those i's out first. So we have negative 1 plus I square root of 70. Will that simplify? If we think about any numbers that will divide into 70 evenly, I do not believe it does. So I'm going to leave it as square root of 70, but the square root of 9 is 3. Over here, we have negative 1 minus I square root 70 over 3. Again, we could shorthand that because the only difference between those two answers is that sign in between. So we could write that as positive or negative I square root of 70 over 3. All right. This last slide is a you try. So pause the video here, see if you can find the solutions to those 3 examples, and then unpause the video to see the solutions. Okay, so for number 1, we get the 2 solutions, x equals -2 and x equals 20. Number 2, I wrote 2 different ways. So the first way we could write it, x equals -4 plus or minus root 26 over 2. Or we could write that as x equals -2 plus or minus the square root of 26 over 2. Those mean the same thing. They're equivalent answers. Number 3, x equals 8 plus or minus 2i square root of 159 all over 7. I guess I could rewrite this as 8/7 plus or minus 2i over 7 times the square root of 159. Again, those are equivalent forms. They mean the same thing. Okay, guys, that concludes the lesson on completing the square.